Hey everyone, Geophysicist Stefan Burns here. The past 48 hours of solar activity in space weather has been insane, and this is likely to continue for the next few days. It could get a lot crazier. That is certainly possible. I would say right now we probably about a 10% chance of a modern Carrington event occurring because of this sunspot group right here, 4366. It has all the requisite characteristics to blast off something truly legendary. It has not done so yet, though it did blast off a triple X-class flare just yesterday. That was an 8.1 X-class flare at the peak, but also immediately afterwards there was a 1.5 and a 2.8 X-class flare. We covered that on the live stream yesterday. That in general did not release that big of a coronal mass ejection. Most of the plasma was reabsorbed into that sunspot group. And well, that's actually not really good news for us, because if it had done a big ejection of plasma, then from here, it would have only been like a flank impact, because this is not exactly Earth center and direct yet. It's on the Earth facing side of the sun, this sunspot cluster, which is still growing and getting bigger at this moment in time. We'll look at the intensity gram, we'll look at a variety of different parameters and data. I'll give you the entire download in this video, catch you up as well. But the closer it gets to Earth center direct bullseye, well, then that risk factor goes up for another really big solar flare and perhaps a really significant coronal mass ejection launching straight towards us. And also that risk factor of a modern Carrington event also ticks up and up and up. I think that 10% figure is really just a minimum. It's basically pretty difficult to actually give a really precise, accurate forecast number for that, because, well, the Carrington event was 1859 and a lot's changed since then, and we haven't really seen something like that. So these numbers, take them with a grain of salt, but in general, this sunspot could be capable of producing a coronal mass ejection strong enough to give us that sort of geomagnetic storm, which would have severe technological implications, because during the Carrington event, 1859, we had massive short circuiting and electrification of telegraph lines. Some of them melted. There was a whole bunch of crazy, wacky things that happened. And we have other examples throughout time. 1872, 1921 are clear classic examples of similar effects taking place. But during the modern technological age, we haven't had something like that yet. So to kind of back up really quick, a Carrington event, you can define it as being a combination of factors that are all basically the strongest that they could be. So it would be extremely high velocity, coming in at less than 20 hours after it exploded off the sun. This is 2,000 to 3,000 kilometers per second. We're looking at a magnetic field that's extremely strong within that solar storm. So probably 80, 90, 100 plus nanotesla for the total field strength. And we would need a negative magnetic field polarity to connect to Earth, so you have that really powerful geomagnetic storming. We would need, in general, a really big coronal mass ejection, aimed towards us. You can have a Carrington event that launches off away from the Earth and doesn't hit us. That was basically July of 2012. There was a Carrington class coronal mass ejection that launched off. It didn't hit us. It missed us by 7 days. If it exploded 7 days earlier, it could have been bad. And you need the sunspot to do that. Now, the size of a solar flare is not directly connected to the size of a coronal mass ejection. There is a correlation there. In general, the bigger the flare, which is the stronger the explosion, the more likely it is to produce a big solar storm, but it's not a one-to-one ratio. So you don't necessarily need, let's say, like an X50 solar flare to generate a Carrington event. You're more likely to if that was to occur, but it's not a necessity. There are other factors. The fact that this did launch a coronal mass ejection out from that 8.1 X-class flare that is going mostly to the north, but also is going to slightly clip us, and it's kind of slow, means that there is a little bit of plasma now loaded in front of the Earth. And so if something big was to launch, it could catch up to that, compress it, add it into its shockwave, and trigger a stronger EMP effect when it hit the Earth. And so if it slowed down the velocity a lot, then that's another drawback, let's say, to not having a Carrington event, because you need that super high velocity impact as well. It's like all the stars aligning, you could say, or this star aligning. But in general, we do now have some plasma in front of us because of all this activity. This hasn't been completely non-eruptive. There has been some plasma launched off. We have the Earth supercharged right now because of all this extreme ultraviolet and X-ray light flux hitting the planet effectively continuously as a result of these non-stop M-class and X-class flares. We have the radiation belts fully charged right now. So the Earth geophysical energy system is locked and loaded, ready to go, saying, hey, I'm ready for the big storm. I'm going to give you the maximum that I got. Now we're really just waiting on the sun. We had a preview effectively of what this sunspot can do. Maybe that's all she wrote. That is certainly a possibility. I want to go through all the actual possibilities, right? You know, this could be the biggest flare of the sequence, but the fact that it didn't have a big, giant coronal mass ejection means most of that energy is still locked within there. And in fact, this sunspot is getting larger. Check out the shock wave on that 8.1 X-class flare. This is from Halo CME. I'll link this in the video description. This guy puts out these videos for these really big explosions on his X account. They are really fantastic. And so we do see that there was, in general, you know, this shock wave that was generated as a result of that 8.1 X-class solar flare. Of course, that 1.5 and 2.7 as well, or 2.8 rather. And there was a 1.6 X-class flare that occurred just a few hours ago after this 8.1. So we're not done yet. We'll look at the X-ray flux. Before we do that though, I want to show you the growth of this sunspot 4366 over about the past 2 days or so. So we see it rotating closer towards Earth center and direct. But in general, there have been bigger sunspots on the sun before since our record keeping began for this. But this is now getting into that top category. It's not the largest we've ever seen, but it is certainly a sunspot beast. I mean, it is now getting bigger and bigger, so it hasn't stopped growing. And in general, it's doing a good job filling in its intermediate portions with new flux. So you'll notice from the beginning to the end that a lot of these regions here on the side have gone bigger and thicker. In general, showing their magnetic fields getting stronger. This was the time period right there when we had a lot of that activity with that 8.1 X-class flare. We had an extreme amount of mixing right here. You'll see all of a sudden right there, that form, that mixing of the cores and of the sunspot, basically polarities, really is what drove that big explosion. And so now that some of that has broken up, activity has gone down as compared to the 8.1, but in general, the sunspot's gone bigger, it's gone denser, and we are still getting areas filling in the middle. So at any point, we could have kind of a return of this sort of polarity mixing and this torque and tension and everything build up. That's certainly possible. And the bigger the sunspot cluster overall, the potential for a bigger solar flare increases. So it's, again, none of this is one-to-one. There's so many dynamics here that you just can't simplify it down and be accurate with that. If you want to be accurate, you have to bring in all the nuance. But this is becoming a huge sunspot group, and it's becoming incredibly active day by day. It's only been on the sun now for about like 3 days. It's been 72 hours roughly, no more than 96 hours. Let me show you our X-ray flux on the sun, and this will show you what's been happening. So here we see January 30th, right at the turn of February. Literally the moment it became February universal time, boom, we started going crazy. And one thing to note is just how this increase in X-ray flux has gone up. This is how we measure solar flares. The amount of soft X-ray light that they release, we look at this at a logarithmic scale. So these are order of magnitude jumps, 10x each time. We have classifications for these flares, A, B, C, M, and X. X starts at X1. We had an X 8.1, so we nearly reached that level above X, though they're all called X flares after that. That is that event right there. But what we often see is that the size of a solar flare will go up 10 or more often 100 times stronger in general than where it was right before the flare occurred. So for example, right here, we see that it had a X flux rating of 6.6 C-class territory or so. Then it went up to 8.1. So that's more than 100 times greater because it went from C to M, and then it went from M to X. So right now, you'll notice that we've been building higher and higher bases each time. Each day is like basically raised up the foundation baseline. And so if we were to build up to a really big solar flare from this, which is like low M class right now, we see that we just had this 4.0 M class flare. Here's that other X class flare, that 1.6 X class flare. If we were all of a sudden to have a 100X go off of that, we could be looking at a very, very big solar flare. This is like X30, and sometimes it's not just a 100X scaling factor, it's like 200X. That'd take it to X60. Now the possibility of this is not the highest of all the different probabilities, but it's not a 0%. I think it's actually pretty high. So that's why we have to be accurate with this and not just bury our heads in the sand. The fact that the Carrington event happened is proof that it can happen, right? It's not like these things from the past never happen again. Volcanic eruptions are going to keep happening on our planet. Big earthquakes and megaquakes are going to keep happening on our planet. Giant solar flares are going to keep happening on our planet. Miyake events are going to keep happening on our planet. It's just what the Earth and the Sun and the cosmos do. At times they have these sort of events. It's nothing to necessarily be afraid of, though the effect of, let's say, a modern Carrington event could perhaps be severe. We're talking about some pretty severe technological problems, perhaps power grid failures, either localized or maybe even more widespread around the globe, especially high latitude areas. We're talking about GPS failures, satellite failures, communication failures, radio, telecommunication failures. So it could be really intense. And there's biologic effects to all this. There's also Earth geophysical effects to this. But in general, it's whatever it is, right? Like God is the one driving this. So you just got to trust and have faith. Now, if we look at our D region absorption map, we can see how much the Earth has been ionized and charged up as a result of all this activity over the past 24 hours. And it's basically been nonstop. So this extreme ultraviolet and X-ray light, it does not get to the surface of the planet in a significant way. Almost all of it gets absorbed at the ionosphere, which is the uppermost part of the atmosphere, which is called the ionosphere because it's made up of ions or charged particles. So those charged particles, they have charge. They're now creating electric field potentials. And in general, you have these electric currents that pulsate. That is then inducing telluric currents in the oceans and Earth's crust. And there's a lot of interesting and complicated geophysics that happens here. But usually, for example, there's no solar activity. The ionosphere is relatively decharged. When it's supercharged like this, the potentials are way higher than normal. Those telluric currents are a lot stronger. Every single sort of solar flare impact like this, the light photons 8.3 minutes later after the explosion on the sun, right when we see it is when we detect it and it actually hits Earth. That affects radio communication. So during really big events, you get widespread radio blackouts across the daylight side because the light is just going straight to, of course, the daylight side. So our Earth is supercharged from this event as of right now. Another good thing that happened, thankfully, was that we did not have a radiation storm commence as a result of that 8.1 X-class flare and the overall triple flare sequence. I thought that was almost surely going to occur, but because the magnetic field of that sunspot did not get that disrupted and really blast all the plasma off, it seems to have kept everything contained. There's a bit of a magnetic shield right now around that sunspot, you could say, that's keeping it kind of closed in. So if that hadn't been the case and we did have a big explosion, we would be right now in a radiation storm. But because that is the case, we are not in a radiation storm. But all that effectively means that now as it gets closer to Earth center and direct, that could happen. If it had a big release of energy from here, with a giant coronal mass ejection, we would have only got clipped. Now, it could have still been a very big solar storm impact, but would not have been direct. The longer this does not have that sort of activity, but now it starts to enter into the strike zone, the higher the risk factor goes up. So this is very active right now, multiple X-class flares, M-class flares. Here we see the model from NOAA for that coronal mass ejection launched from the sun. The velocity on this, according to NASA, is about 267 kilometers per second. very, very slow. And it's, going to the north of the Earth and also here to the east of the Earth solar coordinate system. So this is not really going to be much of an impact, though just in general, also something to keep in mind, just because you're not seeing coronal mass ejections go out, these sunspots in general are enhancing the solar wind, especially when there's that much activity. So expect some solar wind turbulence for the next week or so at least, probably all the way until this thing is off of the Earth-facing side of the sun. So just because we don't have very clear examples of coronal mass ejections launching other than this one does not mean that the solar wind is going to be calm, quiet, and effectively smooth sailing. We are going to have some enhanced solar wind as a result of everything that's happening. So keep that in mind. And here we have our differential coronagraph imagery. So you can see what launched from that 8.1 X-class flare. There it is. So it's not a full halo. It's going mostly to the north, but the modeling does show that there may be a very slight impact from that. So it's hard to give an estimate for the geomagnetic storm that we're going to get from that. Depends on the magnetic field polarity. In general, I don't think that's really even that much of a concern because we're really still focused on this sunspot group. But we have seen some plasma launch off, though most of it got reabsorbed. And again, if we get a really big flare, which is a fairly high probability compared to normal, then we could see all that plasma finally launch off. I'd say, again, the minimum for a modern Carrington event to occur based off of this sunspot, the activity that we've seen, the hyperactivity, it's at least 10%. Perhaps more. Maybe up to even 20%. Again, these things happen at times. We could be right now witness to the first modern Carrington event, very soon. It's a possibility. It could have some extreme consequences, but I wouldn't say it's more than 50% at all. Say 50% chance, the majority chance would be that this is similar to what occurred in May of 2024. But if this sunspot continues to grow, then I'm gonna have to update my forecast for you guys. So make sure you subscribe to the channel. I will keep you up to date on what is happening with all this. Now switching over to earthquake activity just for a brief moment, I want to let you know that this earthquake swarm in San Ramon, California has reactivated. We've been seeing this on and off since November of 2025, and we just had one of the strongest earthquakes in this sequence today. If I set this here, we see a 4.2 and a 3.8. So this earthquake swarm is increasing in terms of the overall seismic energy release across this time frame. Now, seismic swarms at San Ramon are not necessarily uncommon. They sometimes occur every 5, 10, 15 years. We haven't had a big earthquake in this location though in a while. So just wanted to let you know that this is popping off right now, and that 4.2 is one of, if not the strongest earthquake in this sequence. I think there's been another 4.2, but it hasn't gone beyond that. So this swarm is still very, very active, and with all this solar activity and with all this geophysical energy charging that's occurring right now, it's important to point out these locations on the planet that are experiencing, for example, anomalous earthquake swarming, because that is often a sign of something bigger coming. So we have a history of San Ramon that it's just a swarm and that's it. But in general, you look at it more closely when you have that sort of activity, because we don't have 10,000 years of data here, okay? So we really don't know that much about all this. We have to be, it's better to be conservative and, really look at things closely than just be like, oh, yep, we're totally fine. Don't worry about it, guys. At least that's my opinion. So that is the current state of the situation. The next few days could change everything, and it all depends on this sunspot group right here, 4366. So it has not stopped growing. It's still very dense, compact, and complex until this really shows signs that's breaking up and the activity really ramps down. The forecast of extreme solar activity isn't going to go away. So the next few days are critical as it's now entering into the Earth direct strike zone, and then that bullseye zone will be in about 1.5 to 2 days. That's really the critical time period. So let's say February 4th through February 5th is when we really hope that we don't get some gigantic solar flare and coronal mass ejection to launch off. And again, just to review, the size of a solar flare does not directly correlate to the size of a coronal mass ejection. Again, for example, that 8.1 that we had did not launch that big of a coronal mass ejection. Most of that plasma was reabsorbed. But in general, the bigger solar flare, the bigger coronal mass ejection. So for a modern Carrington event, we would need probably a gigantic solar flare, but a super high velocity coronal mass ejection that has a tremendous amount of plasma density to it with an extremely strong magnetic field, total field strength over 80 at least, I would say. It needs to have a negative BZ component to it, so it has to have a negative magnetic field characterization, and it needs to come in super fast. This is 2,000, 3,000 kilometers per second, and the Earth being preconditioned and energized and ready to go would help the geomagnetic storm be stronger. So a lot of those factors are there. For example, the Earth factors, the sunspot factors. It just really depends now on whether we get a solar flare that produces a coronal mass ejection and if that coronal mass ejection has those properties. So that's why the risk goes down as you consider all those, because they all need to line up, but so far everything is lining up. And we have very similar planetary alignments and resonances active now and that were active in January as were active just before the Carrington event in August of 1859, the Carrington event being early September of 1859. We have a Saturn-Neptune conjunction occurring right now, which is very resonant with these energies. And believe it or not, NASA is about to send astronauts on their deepest space mission yet with Artemis 2. Make it make sense. I hope they really reconsider that space mission for the time slot they have, which is, I think, the soonest that they can launch is February 8th. By that time, this sunspot will be more over here, but there are some other sunspots on the far side. So it'd be better for them to delay when we know that there isn't a mega sunspot cluster on the sun. And that Saturn-Neptune conjunction has a couple expressions. I mean, more than a couple, but two clear expressions I can think of for the Artemis mission if it is to proceed. And that Saturn-Neptune conjunction is February 20th of 2026. Is that Neptune is the ethereal and it is also this expansive just kind of what lies beyond, and that is space. So Saturn would be, we made this accomplishment in going deeper into space than anyone has before, manifesting that accomplishment. The other expression is Saturn is often kind of related to limits and death. And Saturn relates to boundaries and more. So they could be breaking that boundary at the first one, right, and going there and having the accomplishment. The other one could be we do this deep space mission and it actually doesn't work out. And maybe we lose the astronauts. Like, these are both distinct possibilities and they are both archetypally resonant with that Saturn-Neptune conjunction. So the best thing in my mind would be for them to delay, especially with this mega sunspot cluster there. And if you're in space without the protection of Earth's magnetic field and you get a gigantic coronal mass ejection or multiple to hit your spacecraft, that could be what does it in the second scenario. Because you don't put heavy shielding on these things because it's heavy weight and you need to be able to blast off. So, I mean, they have some shielding, but it could be really bad. So there's a lot of things happening right now. In general, this sort of solar activity also just makes people more volatile, and it just raises up the energy level of society and the collective consciousness in general. So expect more volatility just everywhere. So this is economically, financially, this is between people, like maybe in your life, but also at the community level, the societal level, also geopolitically. Expect this more kind of crazy developments. And also we see a marked increase in spontaneous social processes. In other words, could be revolutions during solar maximum phases with this sort of activity at its maximum. It's like a tinderbox, and you set that spark and boom, it goes. So there are certainly things right now across the world that have people agitated, and we could see some very quick destabilizing events to occur as a result. And this could be one of those energetic factors which help push that over the edge. Saturn, Neptune also being related to that as well. Some other planetary resonances coming up in March and April. There's a annular solar eclipse on February 17th, just before Saturn Neptune on the 20th. So there's a lot of things happening right now. This is only adding more energy intensity into the entire mix that we already had brewed up for us. So I will keep you up to date on everything. Thank you all so much for watching. Again, I've been your host, Stefan Burns. If you like this video, then smash that like button. I cover everything that's happening here on Earth energetically. This is solar activity, space weather, planetary resonances, interstellar cosmic forces, and of course, here on Earth, earthquakes, volcanic activity, extreme weather, geomagnetic storming, and more. If you like the sound of that, then please subscribe. Wishing each and every single one of you well. Please take care of yourselves, and I'll see you all very soon.